Hello, this is Susan Poss. I wanted to work with you again in Chapter 2, and we're looking today at solving linear equations. And I'm going to split this video into two parts. So the first one is going to be 2.3.1, and then you'll see a second part that follows up 2.3.2. So definitions first. What is an equation? An equation is a math sentence that states that two quantities are equal. So I've given you a little illustration here with something on the left, something on the right, and an equals mark in the center. That's the way an equation is written. Now remember, we talked about expressions last time, and an expression does not have a left side equal to a right side. So that's how you're going to recognize an equation. Two sides, left and right, that are equal. So here's another form for you. If A, B, and C are real numbers and A is not a zero, then a linear, which means first degree, a linear equation in X can be written in the form AX plus B equals C. And I've given you a little example underneath there. Let's say that the A is 5, and the B is 7, and the C is 13. So the way it would look is 5x plus 7 equals 13. And again, there you see left side, right side, and right here in the center is the equals mark. So again, that's what makes it an equation. All right, so we're going to look at two principles of equality today. The first video is going to show you the addition principle of equality, and then the second video is going to work with the multiplication principle of equality. So the addition principle says if you have an equation with two sides that are equal, in this case I've got A equals B, then it's a legal operation for you to either add the same quantity to both sides, and you see me here adding C to both the left and the right side. That maintains balance in the equation. Or you can subtract that same equal quantity from both sides. So one of the principles that I like to talk about when we're learning to solve equations is thinking of a balance scale. So that if you add something to the left side of the equation, that would throw it out of balance. To bring it back into balance, you would add that exact same amount to the right side. So you'll hear me talking about keeping things balanced. So steps to solving equations. These first ones that we're going to be doing are going to be fairly short and simple. So we're going to be combining any like terms. We're going to try to isolate the variable term on one side. So we want the term that has the letter in it on one side by itself, isolated. And then we're going to solve for the unknown variable so that the final equation has a positive 1 in front of the variable and the equals mark and a number on the other side. So let me see if I can put these principles into practice. So I'm going to scroll down. We're going to see some equations that are in that simple AX plus B equals C form. So I'm noticing that on the left side, I see the variable x, and I want to get that isolated. So the way I'm going to isolate that is I'm going to add 6 to both sides. So you'll see me doing these opposite operations. When I add down my columns here, I bring down the x, the positive 6 and the negative 6, of course, add up to 0. Here's the equals mark. And on the other side, I have 1 plus 6 is 7. So I'm finished. I have it in the form, have the equation in the form, positive 1 in front of the variable equals a number. In the second example, I see the variable term x, and sitting on that left side with it is a positive 17. My goal is to isolate that x term. So I'm going to use the opposite of adding 17. I'm going to subtract 17. When I add down the x column, I bring down the x. You'll see the positive and negative 17 cancel out or add up to 0. And on the right-hand side, I have the answer, negative 21. So again, I have fulfilled the requirement that this is a positive 1 in front of the x. All right, in the third one, the variable term, first of all, it's not an x anymore. It's now the letter z, and it's over on the right-hand side. But my goal is still to isolate that variable z. And the thing that's attached to that variable z is a plus 12. So I'm going to come in here by doing the opposite. And remember, if I subtract a value on the left side of the equation, the addition principle says I have to balance that and subtract the same amount on the other side. So as I'm adding down columns here, you'll see I get negative 6 on the left, I get equals in the middle, and I get z. And of course, then these positive and negative 12s here add up to 0. So I'm finished because I have a positive 1z. The next one contains the variable y, and this one has some decimals in it. And my goal is to isolate the variable y. And I need to, in order to do that, I need to add this 3.4. And of course, to maintain the balance, you're going to see me adding that 3.4 to both sides. So coming down the column, the y column is there. These two numbers add up to 0, so I'll leave that blank spot there. And then on the right-hand side, I have a negative 2.5 and a positive 3.4, which gives me a positive 0.9. But I am finished because, again, notice I have a positive 1 in front of the variable y, and I successfully have isolated that. All right, and this last one I'm going to do before we stop for a minute contains some fractions. And I would like, again, I see the x term there on the right-hand side. I would like to isolate that. So in order to isolate that, I'm going to subtract away this 1 over 20. And I have some videos that show you how to use your calculator, your scientific calculator, which is allowed to do a fraction operation. So you might want to search through my list of videos and see if you can find that. But what I'm going to need to do here, and I'm going to do it by hand, is 3/5 minus 1 over 20. And I can see that the LCD, the lowest common denominator here, is 20. So I'm going to introduce in this fraction on the left a multiplier of 4 both in the denominator and the numerator. I do it in the denominator so that I get that 20 that I'm looking for down there. And then I have to maintain the balance or the equivalency of the fraction. So now I have two fractions that are both in the common denominator, 20, and I can see that 12/20 minus 1/20 equals a positive 11 over 20. And that's where I'm going to stop because you can see I have successfully isolated the variable x. So I'm going to stop right there and then come back with a second video and we'll talk about multiplication and division principle of equality.